Okay, hi everyone. Welcome to another episode of Hack and Tell. Today, I'm very happy to have Arto with us, the designer and creator of the Clarity compiler for Arweave, as well as the whole Swan, ecosystem of compilers. Arto, can you tell us a little bit about it?
Hello. Yes. Yes, Swan was a very interesting project to work on. It was really a dream project for an old compiler hacker like myself. It's not only a compiler, it's also a Lisp language, and I'm an old Lisp hacker, so suited me very well. And we released the 1.0 in October. It's in pretty good shape for people to start bidding on it, and I expect we will do a 1.1 in November
Nice.
with usability improvements.
Amazing. So maybe you could take us through what Clarity is and what the kind of what would you say, inspirational or inciting sort of moment that led to this point was? Like, what was it about this that made sense to build, and how did we get here?
Well, we've all heard the stories over the years of the terrible things happening with badly designed contracts. So when I came upon Clarity, it was a fairly obvious good idea. I mean, that's how you know a good idea, right? It's obvious in retrospect. So yeah. I had to jump on that. I'll speak a little bit more about that when I have my slides as well. So I have some slides about it.
Amazing. Yeah, I certainly remember when we first came across Clarity, which is actually because Albert at USV pointed us to it, and he said that Algorand and Blockstack were building this language specifically for smart contracts that was supposed to at least be safer. We were very excited about it immediately because it's so obvious that language safety is an important feature for these smart contracting platforms. It's been kind of, what would you say? We haven't paid enough attention to it. Right. We owe a debt of gratitude, I think, to Ethereum for everything it's done for the ecosystem. But I think the reality is that Solidity is not really a great language to be building applications that are going to handle or essentially our value in and of themselves. Like, it just hasn't played out in a way that makes us confident with that. So we're very excited to, I guess, learn more about your project and how it works. Maybe you could show us a little bit of a demo, or
let me share my screen and let's take it from there. So I'm going to share my whole screen because I will be showing not only slides but also the terminal and web pages. So hopefully everybody can see this.
We can. Yeah.
Good. And I also posted into the chat. I posted a link of lists. So a list of links. Brain fart. So this is all the links in the presentation, and you can follow along in your own browser as we go along. The link is in the chat. All right. So let's talk about what today's session is about. SmartWeave, I think, will be familiar to most who are interested in the topic. So I won't dwell on it. But SmartWeave also is something that captured me as I first read about it. So with SmartWeave, of course, you've come up with a way to take the bottleneck out, the bottleneck that plagues Ethereum famously, but not only Ethereum. So the computation and transaction processing can move to the client side, and you can execute anything you darn well please. It makes sense. I've included links here for people to read more in case they are unfamiliar with this, but I'm going to assume a base level familiarity with SmartWeave. Then in terms of Clarity, the important things about Clarity are exactly what you mentioned, Sam, that it's safe. And to me, what that means is it doesn't contain foot guns. Solidity has a ton of foot guns. Re-entrancy, the most famous one, leading to hacks that lost hundreds of millions of dollars. But there's a long list of them. And the SmartWeave is using JavaScript, and JavaScript is famous for foot guns as well. I've included a JavaScript foot guns or pitfalls link as well in the link list. So even though it makes sense that SmartWeave is built on JavaScript, it's not necessarily the language that you want to be writing your contracts in, and that's the case then for Clarity. The secondary most important thing is that Clarity is decidable. So Clarity is not Turing complete. I'll get into that in a bit. The most important aspect of that is you cannot write an infinite loop. I think that would be intuitively obvious. So the halting problem means that you never know when you might get hit by a stray infinite loop, and that will never happen in a Clarity contract. And the language itself looks like a Lisp, and that might be familiar to people who used Clojure. It means that for machines, it's super easy to pass Clarity, and also super easy to generate Clarity in case people get into, let's say, the deep end of the pool of what you could do with smart contracts. And it's very easy to analyze Clarity programs. I'll get to that in a bit. And for humans, it might look a little bit off-putting, but don't fear the parentheses. They'll fade away very soon. I've included more links here for those who want an introduction. Now then, my project, which I've named Sworn, is a very simple thing, actually. It's just a black box that takes in Clarity contracts and outputs SmartWeave JavaScript programs. We also have a secondary mode of WebAssembly output, but that's experimental, and as we've discussed over the past months, it probably doesn't make much sense to focus on that, given that we want the resulting SmartWeave contracts to be auditable, and the JavaScript output is perfectly human readable, which facilitates that. Now, one way to think about where Sworn sits in relation to everything is that SmartWeave already supports a number of languages. Clarity is just one more. For example, nobody sane would be writing their contract in JavaScript per se. They would write TypeScript these days. And that means that they already have a compiler in the picture. They would already be utilizing the TypeScript compiler to get the final JavaScript to deploy. And given that, you could think of Sworn as sitting in a similar place, as in you can write your SmartWeave contract either in TypeScript, the default option so far, or you could write it in Clarity. In both cases, you need a compiler to get you the final .js that you're going to deploy onto the chain, or onto the Weave, let's say. Now, as I mentioned, Sworn has another output mode, WebAssembly, but it's not up to par with the JavaScript backend, so we can ignore that for now. Let me show you a little bit of how this works. In the links, you have a screencast demo, but we can also just play back this very same cast on my terminal. The reason I'm doing this as a pre-record is very simple. It takes time for transactions to confirm, and if I did this live typing, I would not only make a bunch of embarrassing mistakes, as when I recorded this screencast multiple times over, but also it would take a long time. It would take 10 minutes for each transaction to confirm in the worst case. So what we're looking at here is that we are compiling first to WebAssembly, the counter example contract. So you can ignore this. This is not that interesting. And then we are going to test it in the WebAssembly virtual machine. That's also not that interesting. But then after that, we shall deploy it to the chain. So now we will get some JavaScript outputs, compile the contract to JavaScript, and deploy that on the chain. Oh yeah, and of course we need the initial state of the counter as well. So that's the JSON file. And then using the SmartWeave CLI, we can deploy it. Here's where we would have needed to wait potentially quite a few minutes. But in the screencast, I sped things up a little bit. So now we've executed a couple of increment calls with SmartWeave, and then we read the counter is indeed, after those transactions confirm, we read the counter state and it's indeed 2 as it should be. And we do a decrement the same way. Again, wait for it to confirm, and the counter has been updated to 1. So that's a very super simple demo of how to use it. And if this was too fast, I don't really have a pause button here when I'm playing this back. If this was too fast, then you can find the same demo in the links. So we have on ASCII Nema, we have the same screencast, and there you have a pause button, which might help. All right, so let's talk about why you would want to change from something like TypeScript to writing Clarity. And Sami already mentioned that Solidity in particular would be a bad idea for writing smart contracts, and who could argue otherwise, given the hundreds of millions of dollars of mayhem already caused. Indeed, the very fork that created, depending on your perspective, either Ethereum as we know it now or Ethereum Classic, was ultimately about language deficiencies in Solidity. So the history of smart contracts is really the history of bugs in smart contracts. And given that, anything we can do to lessen the number of bugs that we get that we deploy to production is a very good idea. And Clarity is exactly made for this. I put together a little bit of a matrix here, just in terms of a few features, a few language features. It's not a comprehensive comparison, only some of the highlights that I consider hugely important. So we are comparing between Solidity on the one hand, JavaScript and TypeScript, which are very similar, except that you have types in TypeScript, and then Clarity. Now, all other languages pretty much for writing smart contracts right now are not decidable, as in they are Turing complete, and that means that you can get stuck in a Turing tar pit. You never know beforehand, is the computation going to halt or not? Is it going to go into an infinite loop or not? Which means that you need some kind of resource control, for example, gas, as in Ethereum. With Clarity, you don't need that. Of course, SmartWeave doesn't suffer from this problem, given that gas is not necessary, given that it's actually no problem in SmartWeave for a contract to end up in an infinite loop, because it's going to mostly affect the people who deployed the contract. But in any case, from the point of view of developer happiness, it might be a nice idea to use a language where you take away some of the unfortunate possibilities. And in that vein, strong typing is an important feature, which is, of course, why people prefer TypeScript to JavaScript. We don't want to be testing in production with a dynamically typed language, deploying on the chain time and again until it maybe works. And you can never be sure about that maybe. So we want some guarantees, and Clarity has a very, very strong type system, static type system. More so than Solidity, but at least on this one, Solidity gets a green one as well, green check mark as well. Now, the next important thing is that there's been a ton of vulnerabilities in smart contracts caused by numeric overflow and underflow. You can look into those and see how massive amounts of funds have been stolen from contracts exploiting unchecked arithmetic. This is less of a problem in modern Solidity, given that there's the safe math library that we ought to be using. But of course, by default, Solidity is not going to check your math. And certainly, if you write JavaScript and TypeScript, nothing's going to check your math unless you pull in a library to do that. So in Clarity, all arithmetic is checked. If you have an overflow, an underflow, or a truncation, you'll always know about it. You'll never be swallowing those errors. silently. Now the next one is null safety. Null is one of the worst ideas ever, as some of our listeners may know. Tony Hoare called it his $1 billion mistake. It certainly caused far more mayhem than just $1 billion. And no modern language is going to include a null, and Clarity is no exception. So we do something else in Clarity, which I'll come to. Error checking. Solidity has a lot of footguns about calling library code. If you're not careful, you will accidentally overlook errors, and then you're in trouble. With Clarity, you need to check error responses. You can't ignore errors, and that's a good thing. Maybe not for general purpose programming. Sometimes you just want to script and get things done, but in a smart contract, you probably don't want to be ignoring errors from library code. So let's talk about Clarity, the language. I mentioned that Clarity is a decidable language, and what that means is that for every Clarity program that you have, you can always know, first of all, that it will indeed guarantee the halt. It will eventually stop. That's nice. But secondarily, you can also know that it's going to use so and so many resources. You can put bounds on the computation that it's going to perform. You can know that it won't take more than this amount of memory, for example. Again, that might not be so important for SmartWeave because you are going to be running the code you wrote yourself on your own resources often. But it's certainly a good property. Now, you might think that this comes with huge restrictions in what you can write, what kind of programs you can express in Clarity. And to an extent, that's true. As in, obviously, if you can't write arbitrary loops, there are some programs that are not expressible in Clarity. But as it turns out, for a smart contract, that might actually be okay. It doesn't particularly affect writing contracts. You have functional programming features for filtering and folding and mapping over sequences, and you don't need to write arbitrary loops. You can perfectly well get your program done in any case. For auditability of contracts, I think that one of the strongest arguments for Clarity that, as no doubt a number of our listeners know, the audit industry, smart contract audit industry is booming these days. As in, there's a backlog at every auditing company. You might have to wait months to get your contracts checked. There are not enough auditors, certainly not enough competent ones, and the demand is just massive and growing. And it's not so easy to audit a Solidity contract, particularly the complex ones that we have these days, that we see these days, where you're pulling in a lot of components that other people wrote, and it can really be quite a big spaghetti mess. And also, there have been any number of cases now where you have audited contracts, but in any case, there are vulnerabilities. The audit is no guarantee. It's a good idea to get audited, but it's not going to guarantee that everything is going to work out, just given the complexity involved. And that's, again, where you ultimately need, I think, non-Turing complete language. You need to get the computer to help you. You're never going to, given the halting problem, you're never going to be able to say with any certainty that a program is going to do what you expect it to do at a certain level of complexity. And so you gotta just winnow down the language to something that can be audited. Clarity is pretty good in that regard. In terms of the safety of the language, I mentioned static typing, but it goes further than you might think. So, for example, Clarity doesn't support arbitrary sequences. You can't create a dynamic list of arbitrary length at runtime. All the sequences must be statically known, and their lengths are part of the type. So if you have a string hello world, the integer 13 is going to be part of that type. How do I know the length of that? Well, I've programmed hello world a few times in my days. The same for buffers and the same for lists. In all cases, you have at least an upper bound on the length of the list. You may not know the exact number of elements, but you will not allow it to grow over this bound, and that's part of the type. So that prevents unbounded growth, and that, of course, ultimately limits the language, but surprisingly, perhaps not as much as you might think. You can still express all the things you would want to express pretty much. And all arithmetic, as I mentioned, is checked. There can be no silent overflow, underflow, or truncation. So every operation must have a well-defined result. Null safety. If you haven't used a language which doesn't have null, the question might present itself: how can you do away with null? And the answer is that you don't permit null values, but you have a type called optional. An optional type can either have a value, or it can have a often called a none value. Now, none is not null because it cannot occur in a freestanding context. It must always occur only in a context where you're dealing with the optional type. And as a result, a massive class of vulnerabilities and bugs are eliminated. And as I mentioned, error checking, you just can't swallow errors. You gotta take care of them. And all public functions in Clarity must return a type which could be an error. It's called a response type, and it's either an error or a value. And we omit a huge list of anti-features from Solidity, which I won't go into anymore. So let's actually have a look at what Clarity code looks like. This is my favorite contract, as in making this compile back in September was a very fun exercise, and this is a nice hello world for smart contracts, I think. So let me walk you through this. This can look a little intimidating if you haven't used a Lisp language before. It's a lot of parentheses, but ultimately, once you get used to it, it's very easy to read. So here we are declaring a persistent data variable called counter. Its type is integer and its initial value is 0. Then we are defining 3 public functions. So 3 functions which can be used from outside of the contract, exported functions, if you will. We are defining a read-only function. So this function can never affect the the contract state, and that's good that you have this possibility to restrict that. And this function, very simply, this getCounter function, it will access this persistent variable and return its value, wrapped in an OK, which is going to construct a response type which isn't an error. And then we have 2 public functions that mutate the state. They're called, obviously, increment and decrement, and they are mirror images. The only difference is the plus and the minus. In each case, in both cases, we get the current value. We either +1 to it or we -1, and we set it back to the persistent state. And then the final line is the same as getCounter, as in we return the current state. We could, of course, have bound the value we just set to a variable and return the variable instead. But this is a very simple contract to understand. So let's look at what we're going to do with this contract. This is the output from Sworn 1.0. So the screencast demo I showed you earlier, that's from a pre-release version, and it was a somewhat simplistic output. This is now the correct output, I would say. So in this case, what happens is that the 3 functions we defined, they get turned each into a JavaScript function, and then we implement the what would you call it? Let's call it the application binary interface, the ABI for SmartWeave. SmartWeave only requires a function, exported function called handle. So everything gets dispatched through this function. Now, in case you had a function that wouldn't be public, then you wouldn't have a dispatcher here. You would still have the function here, defined as a JavaScript function, but you wouldn't have an if statement that can actually get at that function from outside of the contract. So this is fairly readable code, and one of the important priorities for Swan was that all contracts can be compiled into pretty printed beautiful code. As in, we use a fairly advanced pretty printing algorithm that is going to correctly wrap lines at 80 columns by default, and it's going to produce very human readable code. There are still tweaks I can make to make that prettier in all cases, but generally the contracts I've tried, it's very readable code. And if code isn't readable, that's a bug, so send me a bug report. Okay, so if you look here, what's happening when SmartWeave calls the handle function, passing in the current state of the contract and passing in the action to perform. Here we see a difference between the read-only function and the mutators. So in the case of the read-only function, we will call our internally defined function, and it will return the current counter value, but it has no chance to mutate the state. To mutate the state, it has to return an object that has the state key, and that's not the case for the read-only function. It really has no chance of mutating the state. And for increment and decrement, on the other hand, we give access to the state, access for changing the state and returning the new state. So in this case, the state does get changed. So that's a short overview of input and output. And I'm collecting examples in the Swan repo of contracts that I know compile nicely, and of course any contracts that don't compile ultimately file bug reports for me. As an FAQ, some people have asked me why we have to call out to the add, multiply, subtract, and divide functions, and that's of course so that we can handle the overflow. I won't dwell on that. Here's a short table of how we map the types from Clarity into ultimately JavaScript. I've included TypeScript just so that you can see perhaps at a better level of granularity how things work. Shan't dwell on that. As for the future, we've had a lot of talks with Sam about Swan 1.1, 2.0 and beyond. And as I mentioned, the 1.1 release will be in November, and the #1 priority is user experience. So to improve the UX, error messages are important, and particularly for people who are new to Clarity, we need to aim to give much better error messages than in 1.0. For 2.0, there's some pretty ambitious plans. This is still all experimental, but I'm working on passing Solidity contracts as well as Clarity. You might wonder why, given we just didn't speak of Solidity in the most endearing terms. And that's very simply providing our migration path from the Ethereum ecosystem to Arweave. So we want to support some subset of Solidity contracts. Just being able to bring your existing contracts over, and Swan will compile those two in the same way. There's a ton of work on Clarity.js and SmartWeave integration. So Clarity.js is the runtime for Swan, implementing, for example, the checked arithmetic and hash functions and all of that. It would be really cool to do Clarity functions for super easily building profit sharing tokens and communities that could use a little community love if there are people interested in that. And Clarity is already available in some form on 3 blockchains as of this moment. on Arweave, of course, and Ethereum and Stacks. I'm working also on the Ethereum implementation. So that prompts the possibility that Clarity could actually become something of an industry standard for cross-chain contracts in the future. The Stacks Foundation is certainly positioning it as such, and I imagine that that has Arweave support as well. So that's the end of the presentation segment.
Amazing. Well, thank you so much for showing us that. That's all very impressive. I guess I had a lot of questions along the way, but the first, from like an outside perspective, would be, how can I get my hands on this? How can I start experimenting with it? What's the best way to get going?
Yeah. So we have a very simple installation process right now. You can download a single binary for Linux and Mac. Windows coming soon. I still need to build a Windows build machine. And you just wget that, and you have the compiler. There's no dependencies, no nothing. It's super simple.
Wow.
Let me see. I'll put in the installation link to the chat, and you can find it, of course, in the README for Swarm in the GitHub repo.
Awesome.
Let me just paste that link.
Another thing that came to mind while you were demoing was that it's really impressive to see that the output JavaScript is actually readable. I think this is so when we were building SmartWeave, we kind of expected that JavaScript would become like the assembly language, if you like, and then there would be languages built on top. We're certainly at that stage much faster than I'd expected, but what I hadn't expected was that the assembly language equivalent would actually be readable. That's very impressive. How are you able to do that? Go on.
I can't take credit for that, unfortunately. As in, that's kind of a side effect of doing the compiler in a language meant for compilers. So the compiler is written in OCaml, and OCaml has actually in the standard library a very advanced pretty-printing algorithm. And basically, if you use that, this just drops out as a given. We do need to do some fine tunings in some cases. We have to basically encode the language rules of JavaScript for how things ought to look, but it's not that much work. It really is very nice output.
That's really interesting. Another question I had was, how complex do you think it would be to include some code written in JavaScript and some code written in Clarity? I was just thinking about a new initiative someone's working on for what they call PSC plus contracts. The idea is that you get a profit sharing community and you can make it so that you can inject code and then have that code execute, first voted in by the DAO and then executed when people call the contract. So it's kind of like an extension system, essentially. I was wondering how hard it would be to write those extensions in Clarity or potentially later Solidity.
Yeah, this is a good question. We were talking with Cedric along these lines that it's kind of necessary to be able to first of all call all of the functions available behind the SmartWeave global in JavaScript. We need to expose those to Clarity. They are not currently all exposed.
Interesting.
We expose some things like the block height and so on through the Clarity.js runtime, but we have to ultimately decide on and settle on and implement some mechanism that lets you at least access everything in the SmartWeave global, which is going to then be Arweave specific extensions to Clarity. I doubt Stacks is going to do the same.
Okay, got it.
And we probably want something. Basically, what you're suggesting is a foreign function interface for Clarity.
Essentially, yeah.
Yeah, and that's certainly something that I think a lot of people would want. But we should probably take some care in designing that. We'll have to support it ever more.
Right, very true.
Yeah.
That's very interesting. And just a point of curiosity, do you know any more about the 128-bit precision on the integers? That's always been something that has struck me as a little bit, like I didn't immediately understand where that came from. Do you have any more background or?
I think that, so I don't know for sure, but I think it comes from the fact that 128 bits is probably enough. So Ethereum went a little bit overboard. The 256 is maybe too much,
right?
at least for right now. And with a few chains that I'm involved in, 128 bits seems to be the sweet spot. So I think that's what it's about.
Yeah, I always assume that they use like 256-bit in Ethereum so that you can just take a hash and make it into an integer if you want.
Yeah, that's probably driven by that. But ultimately, 128 bits of a hash is already pretty darn unique.
Yeah, that's very true. Interesting. Okay, amazing. So I think you guys have, or you, I think at this point, have a Discord server, right? Is there a way for people to get to this, or how can they keep up with the project and join it?
Yeah. So of course, I've been posting updates to the SmartWeave channel also on the Arweave Discord. But I do have a dedicated Discord called Weavery. I'll put in the link here as well, and you can put it into the show notes.
Awesome. And is there anything in particular that you're looking for that the rest of the community might be able to help you with, potentially?
The most important thing would be that we, the compiler is pretty much complete. There's not that much that I ultimately want to change in the compiler. We can always fix bugs and improve things, but the compiler is the easy part. Now we have the integration with SmartWeave and access to all of the block data and so on. Plus this perhaps we could call them primitives. The primitives for easily building PSTs and PSCs. Those are things that probably on the one hand Arweave needs to be involved in, because again, these things need to be able to run forever. Given how SmartWeave works, we need to always be able to run code that we put out there. And secondarily, I don't have necessarily the bandwidth to take on all of those, all of the deliberations and implementation myself. I'm pretty focused on the compiler. So anybody who wanted to basically work in the intersection between SmartWeave and Clarity.js/Swarm, that would be highly welcome.
Interesting. Yeah, I think there's definitely some obvious work to be done porting over the existing token.js contracts, which literally is actually written in JavaScript. So putting that in Clarity would make a lot of sense, as well as Cedric's profit sharing community. I think it's just called community.ts, I suppose is the contract name. Anyway, the default profit sharing community contract, that can make a lot of sense to put into SmartWeave, although it's actually getting quite complex at this point. Not SmartWeave, Clarity. It's getting quite complex at this point, so I wonder how much appetite there is to do that. But I know that they're also switching to this extension system, and so if we could get that FFI in there, that could be really interesting, because people could then build on top of it. And the hope is that basically the profit sharing community contract just becomes like this absolute base layer thing that really doesn't have to change very often.
Yeah, this is important. I mean, one of the good things about Clarity as used on the Stacks blockchain, they ultimately are able to define something like a new token with a couple of lines of code, because that's been how would you call it, abstracted away behind a couple of functions, a couple of primitives. And ideally we would do the same, because for example, let's say I wanna deploy the contract for my profit sharing community, Weavery. Ideally, that should be just a couple lines of code, right? Yeah. It shouldn't be more than that.
Yeah, for sure.
But we're not quite there yet in terms of how to do that.
Yeah.
Nothing to do with the compiler. It's all questions about how things map to each other.
Right. Yeah, I mean that begs questions of I wonder if we can have inheritance essentially. So because a profit sharing community contract inherits a lot of the basics from a profit sharing token actually, and you could see that this is just a kind of, I don't want to bring object oriented programming into it, but
right. No, the way I figure it is that the way I figured is that we would define a few primitives for our Clarity version. So AR- something or another. That lets you define exactly the standard contracts for PSTs.
Yeah, behavior or something.
Yeah, and then the implementation can very well be the existing JavaScript. We just productize it behind an easy interface.
Interesting. So you mentioned the profit sharing community for Weavery. Do you have any more details on that, or I guess
not as yet. I've been too busy coding, but I better get to that so that we can incentivize a little contribution soon.
Yeah, I think that'll be very interesting. It's one of the first ones where someone's building a profit-sharing community for a piece of code that runs kind of locally to the machine. So it's not really on-chain per se,
right?
Just contributing tips on-chain.
I think that can be different than everything else.
Yeah, definitely. Okay, amazing. Well, is there anything else that you would like to broadcast to the community while we have the opportunity?
No, I think that covered pretty much it. Very happy to talk to potential contributors, and we'll bake you into the profit sharing community as it emerges.
That'll be amazing
from all the coding.
Okay. Well, thank you so much for your time, Arto. It's really great to see how this project has progressed, and I'm very excited to see where it goes next. Having this sort of family of languages on top of SmartWeave was like, I guess, always the long-term goal. But like, it's amazing to see how quickly we're getting there. So that's really cool.
Yeah, it's a cool project. I love working on it.
Amazing. Okay, well, thanks so much for your time. See you.
Thanks, Sam. Bye-bye.